Welcome back to UVA Data Points. I'm your host, Monica Manning. In today's episode, we're bringing you a conversation recorded live at UVA Data Science's Datapalooza 2022 event. Datapalooza is a flagship event for the School of Data Science. It's typically held each year in November and features presentations by researchers here at UVA, as well as friends and collaborators at the School of Data Science. In this episode, we're featuring a panel discussion between Doug Hague, the Executive Director of UNC-Charlotte School of Data Science, H.V. Jagadish, Director of the Michigan Institute for Data Science at the University of Michigan, Phil Bourne, Dean of the UVA School of Data Science, and Micaela Parker, Founder and Executive Director of the Academic Data Science Alliance. Micaela also serves as the moderator for this panel discussion. This conversation starts off with Micaela Parker, but I also jump in a few times in the beginning to let you know who's speaking. So with that, here's a conversation on the future of academic data science, live from Datapalooza.
So I'm going to read off a little bit of longer context for this first question, and then I'll sit down and we can take answers from the panel. So a hot topic in data science news right now is that AI is capable of generating photorealistic images purely from a text description. And that is a pretty impressive advancement. But there are many ethical issues around this approach. The models are trained on images scraped from the internet, usually without giving credit, recognition, and certainly not compensation to the original artists. Furthermore, some of these AI-generated images are remarkably realistic and can therefore have the potential for harm. Some companies are using easily identifiable watermarks to make the AI-generated images distinguishable from a real photo, but are these easily overcome when misinformation is the goal? This particular example also touches on the concept of openness, which our communities often advocate for, open data and transparent workflows, but using openly available data without any credit obviously is also problematic. So this example brings up a lot of questions, and I'm going to sit down. You guys mull for a little bit what I just said. So the first question related to what I just said, I think oftentimes in the news, and this is for the students in the room and myself included actually, that often data science and AI and machine learning are conflated. So how do these two fit together? How do data science, machine learning, AI all fit together? And also, if you want, comment on the intersection with respect to the open movement.
All right, well, I'll start.
Jump in, Doug.
I'll jump.
Speaking now is Doug Hague, the Executive Director at UNC-Charlotte School of Data Science.
So AI, machine learning, and what was the other term you used? Data science?
Data science.
Yes, they're all interchangeable, and the basic answer is yes. And doesn't really matter, maybe it does, the definitions and how they fit together, because they do fit together. And trying to understand the purest of AI, and maybe not generalized AI, but maybe generalized AI, which is where you're, trying to act like a human brain. But the more narrow AI, the data science, to my viewpoint, data science is a general term, and AI and machine learning fit underneath. But then I know some of my compatriots flip them around, but they all are very heavily related to each other. We all use algorithmic techniques. But I think the data science is the broader one because it brings in more carefully the ethics and also the other fields like sociology and humanities and other pieces that AI generally means the algorithm, but not always. So I'll pass that on.
Well, a panel isn't fun if we agree, but unfortunately, I'm in the position of agreeing with Doug.
Speaking now is H.V. Jagadish, Director of the Michigan Institute for Data Science at University of Michigan.
So my take on this is data and the algorithm that one applies are complementary. And it's simply a question of where you begin and how you identify what you're doing. So data science, we begin with the data and say use any analytical method you want. AI, you're applying AI techniques, and you need lots of data for any AI to work. And so they go together. When one looks at it from the perspective of any application, which is one of the important distinguishing characteristics of data science as a field, is a very strong focus on application in a whole range of places. it doesn't matter to an applications person how you draw any boundaries between these fields. And so we, unlike, in fact, Virginia and the North Carolina places that are here, are not a school of data science. We are an interdisciplinary institute. And so for us, it's actually an existential issue of, is there room for somebody to be doing an AI thing on campus? And the answer is no. And so there was this small side conversation at the beginning of the session, which is that we at Michigan have a very clear official statement of where the Michigan Institute for Data Science is the name, but our scope is data science and AI. And that is interesting because AI as a topic is typically a part of computer science. And data science as a topic is not a part of anything else. So these things are not symmetric, and but working this out was good for us.
Yeah, let me add one other thing, because one of our panelists or speakers earlier today brought it up. And in data science, to me, we talk about what's the problem first, why are we doing this, not how we are doing this. And the AI and the machine learning are typically the how and not the why.
So I guess we have a very holistic view of what data science is.
Speaking now is Phil Bourne, Dean of the UVA School of Data Science.
When we, this really started off when we got the school going. If you take the founders of the school and you ask them what data science is, they weren't all saying the same thing. And I've heard a bit of that already today. So we decided we should at least try and get everybody on the same page with respect to what data science was. So as we do a lot of shared governance and back and forward, we came up with a representation which you've probably heard about in more of the sessions today, if you're not familiar with it already. Of course, everyone who's in the school here is, which is the 4+1 model, where we think of data science as 4 core components, of which analytics is one of them, and that would certainly be where the majority of the AI lies. And then the others are systems, which are the underlying systems that support the data analysis and so forth, including things like cybersecurity. And then there's design, which is really about how humans interact with data and algorithms to be effective. So that includes things like how you visualize the outputs, how you disseminate. And then the last one is value, which is the tension that exists between, which gets to the ethical aspect of how you can produce things using algorithms and data, which have a positive effect, but they might also have a negative effect. And that tension of how you move forward in that framework is how we think about it. So that sort of brings in the ethical piece. And then the +1 are all the application areas where you apply those 4 major components. Just FYI, right now we're actually thinking about how we're going to organize ourselves as a school to actually reflect that, how we think about data science, with the idea that people have a sense of belonging to one or more of those areas I mentioned, but at the same time have all the capabilities of working together. Which, frankly, does not happen the moment you start introducing departments and things. You're putting up walls, you're creating silos, you're creating resource allocations that may not be equitable across the organization. So this is the great fun of doing this, is to actually try and come up with a model that is going to allow us to move forward in a way that's most effective to address some of the issues that Jim Ryan was alluding to when he spoke to us a minute ago. And then if I go on to the openness piece that you mentioned, there's a lot to unpack in the question you asked.
I know.
And I would probably, we talked a little about this in the opening session this morning, but just to elaborate a little, data science, in my mind, would not exist if it wasn't for open data, open methods, and a lot of sharing of protocols, workflows, and so on. So how how could we possibly not be part of that movement? If we took all this away and did things with it, we have to give back. It's the right thing to do. So that's a mandate, and people joining the school sign on to that mandate. At the moment, it's a set of guidelines. So we have some open scholarship guidelines that faculty sign on to. And it's really an opt-out model. So it's a model whereby you agree that all of what you do, all your research products, which is a variety of things, data, software, and so on, protocols, papers, are made available openly. You can opt out if, for whatever reason, you've got this hot thing you think you can publish in science, then of course you should publish that in science. But you should also try and come up with a preprint or to publish somewhere else. But anyway, the point is that there's this openness that by some miracle, which I still don't, miracles can happen, that set of guidelines went before our faculty senate and was adopted by the whole university. And so we're currently in the process of turning those guidelines into a policy for the university, which then will be followed. And all this is happening in alignment with what's happening in federal agencies around the need to have open data and open publications. So a lot more could be said about that, and I'll stop prattling on.
So I do have a follow-up question about ethics, but if either of you want to comment on open.
I was going to say the open data, maybe we get to the ethical questions to your opening statement.
Yes.
Your opening statement, we had very open data. There was Pinterest, the training teams on their AI scraped the internet for what was generally given for maybe not that purpose, but for other purposes that was open, that they then reused for other purposes. And then what's the ethical reasoning and what's the ethical purpose of that? Do you need to be able to compensate your artists? Do you need, they freely gave it so that they were making their commercial and gaining their sales that way, but what was the process? So I immediately went to our faculty that are in philosophy, and we start debating, what's the right thing with this? And it's not a clear cut. They initially brought up Spotify, right, and sampling. And so what's the legal framework around sampling? But then is the legal framework actually the moral and the justice? Is it actually a just practice today, or do we need to change the legal framework as well? So all those questions are actively debated, and we bring them up, and it's actually interesting and fun to debate and understand and better our world that way.
Jag, do you have any open comments?
Well, I think that there are often conflicts, sometimes trumped up conflicts between openness and privacy. And people who deal with data need to understand where those boundaries lie, because often people will use a very broad brush stroke to use privacy as a means to avoid openness. On the other hand, there is a tension in some situations, so we need to recognize what those are.
Yeah, thank you. So now I promised I would get a little bit deeper into ethics. And this is more from organizational level, since you all represent different institutions and institution types. Data science is inherently hyper-interdisciplinary, involving a breadth of fields. Where is data science being taught on your campus, and how do you see ethics effectively incorporated into data science training? And why don't we start at the end, Jag?
Sure. So we have data science being taught across a number of units on campus, and we ourselves at our institute offer a data science certificate, which is only open to graduate students, and it's in conjunction with another degree program that they're already doing. So this is like a minor for grad students. The ethics is a requirement in most of the programs, and usually it's something stuck on the side, which doesn't seem to be enough, because students don't take it seriously when it's divorced from the bulk of the material and feels very different. And so right now we are in the process of trying to retool many of our courses, particularly lower division undergraduate courses, to add an ethics component to it, which is quite a bit of an uphill battle because every course there's always a lot of stuff that we all want to cover, and you can't add material if you aren't taking something else out, and that's basically where we are. We're in the process of doing that in the early days. We've got a couple of courses where we've done that.
So yeah, it's an interesting question because as I was going through and getting my bachelor's degree approved, one of our humanities faculty stood up and said, well, where's your humanity in this? And I was like, well, I don't know. Let's go talk about it. And what we ended up doing is bringing our humanities and our philosophers into our program. And so it expanded the breadth of the school before I even got it approved. And what ended up happening is we ended up bringing, and this is our undergraduate, and I'll talk about the problems with our graduate program here in a minute. But we scaffolded ethical, what's called a student learning outcome, through every one of our data science classes. So you have to reckon, our first semester freshmen now recognizes their specific efforts and training that go through to recognize an ethical situation. And by the end, you're doing an ethical audit, an understanding and challenging and doing it. And along the way, you're looking at multiple viewpoints and writing a lot. We have a lot of writing in our data science, which surprises some of the students. But that ethical reason is actually embedded in all of the classes. In our graduate programs, we have the course, the one course in ethics that you're going to take that the students then promptly forget about. And so that we didn't feel that was good enough. And so we're trying to blend it in to all of our courses now, but it's challenging because you have so many things to teach in each class that you have, and how do the students best absorb it and incorporate it into their daily practices. And that's really why we went to this extra effort, but it was involving our philosophy and our people that really think about this all day and their methods, and then bringing it into the data science education program.
So two parts here. One was the where data science is being taught, and the other part relates to how ethics fits into that. So I'd say for the first part, it's absolutely, I think, really fortunate for us that we are, as Doug is as well, a school, because that gives us autonomy within the institution with respect to all of the things we do. That might sound, who cares, but it actually turns out to be very important. So when courses go forward, they're reviewed and programs go through the provost office, so that there's an attempt to actually unify so that things get taught appropriately. There's not a lot of overlap and so on. This happens at the state level between institutions as well, but within the institution, that's what happens. So then it allows us to then work in concert with others in other schools. So an example would be that we have a Department of Statistics, and they offer a course in statistical data science. Well, I think it's really important that we know that and we work with them to actually understand, because what is relevant to the student. I always look at any of these things through the eyes of the student. The student should have a very clear understanding of what each course program is going to provide to them, so that they can make the most informed choices for their own interests. And we have an obligation to make that as straightforward as possible, to make the similarities and differences between our respective courses and programs as obvious as possible. It's not always trivial, but that's really what we aim for. And then with respect to the ethics aspect of this, we're focusing on how this is taught, but I think there's actually something even more fundamental than that. And that is the culture that you instill in your data science entity that then ultimately is reflected in what gets taught. Also, how you research. So if you're very active research as well as teaching, those two are interrelated. So if you're doing research that in some way is unethical, that's going to bleed over into how you think about how the person teaching, who's doing the research and then teaching, how that affects the course and so forth. So I think it's really important to think about the culture of your organization to make it as ethical and just as possible. And when you have, as we all do, a variety of students within the programs that are going to have different graduation interests. So it could be that it's very analytical, that brings into one set of ethical characteristics, but then on the other hand, they could actually decide to go into policy and law, where data, as it relates to data, that has other kinds of implications. So it's actually taking those ethics and in some ways working towards making them policies and laws. So there's quite a gamut there, and these are challenges. They're challenges when you have something as broad as data science.
Yeah, just to keep going a little along that thread and pull a little bit maybe more for schools that don't, I should say for universities that don't have schools of data science or departments of data science. Often we see data science training happening out of the CS department or stats. What would you say to those schools? How can they reconcile incorporating ethics? Is ethics lost when a CS department or a stats department, the end point of the learning is the learning of the tools and the techniques, not the application? It's not like an application-based, like data science. Do we lose ethics if we have data science being taught in these types of departments?
So let me take that, because that's very much the case for us. Our undergraduate data science program is jointly taught by computer science and statistics. And what I was saying about ethics being incorporated in lower division undergraduate classes is something that is benefiting not just the data science students, but also the computer science students, because the lower division classes are shared. And I think that there is, in general, a broader understanding of ethics in computing overall, and maybe computer scientists are a little bit behind data scientists in terms of when they entered this conversation, or to what extent it's high on their radar screen, but it's there. And I think that the interaction actually has been positive.
Go ahead.
Yeah, one of the things I'd say is I agree. The computer scientists and statistics, they're worried and they're working through the ethical reasoning and bringing that in. But one of the challenges is, do you have experts in that? And so some of the computer scientists have turned into experts in ethics. But one of the things that's my blessing that I have is I have 3 or 4 philosophy faculty that are also part of the school. And the way they think is just different than most computer scientists. And in fact, almost all, even the ones that are trained in ethics, they think in a different manner, which brings this culture that's a little bit different than a pure computer science or computer statistics that I actually like. Now, it's very hard to build that culture of allowing them to speak and bringing the timing of that so that it's coming at the right time. But that's one of those things that I think the school has an advantage right now. But it's not that computer scientists and statistics departments and the people that are teaching it aren't ethical, right? They're working through this as well. But bringing in one of the things I think is the interdisciplinary nature or the breadth of data science and the diversity of viewpoints has been very beneficial to us.
Did you want to comment, Phil? Or?
No.
Okay. So we're going to turn now to frameworks for data science on a university in terms of degrees. So starting with, how should a student decide between a major or a minor in data science, or a certificate, or a transcriptable option? And how do these different options reflect their hireability, essentially? And if you want to weave into that components of bachelor's, master's, PhD, that's fine. But really, let's start with the core question of, how do you advise a student if they're looking to be on the job market? Which of these options is the right one for them?
So I can begin. I feel that ideally, a university should be able to offer a degree with some appropriate label for any set of sufficiently challenging courses. And I think that that's organizationally very hard to do, and most universities don't end up managing to do that. But in terms of what is actually available and what is possible, I would say there's a place for somebody who wants to get a degree in discipline X and learn a smattering of data science, somebody who wants to get a dual major in X and data science, somebody who wants to do data science with a minor in X, etc. Right? These are all perfectly reasonable and perfectly valid decisions in terms of which field to go into, and I think people don't often have, I don't think that small differences matter in the long run, and there are many paths to leading a successful and happy life.
Go ahead, I'll follow you.
All right, so one of the things I'll say to that is, just look at us up here. None of us have a degree in data science. Nope. I would bet, right? None of us, right? I'm assuming.
Oceanography.
We're all old enough, right, that we don't, the data science didn't exist. But one of the things I did when I started this role was I actually took on advising of students. So to be able to answer some of these questions, and what I ended up finding out over time that actually worked was asking the students about their passion. What did you want to be passionate about, right? Do you want to be passionate about how a computer works? Then you need to be a computer scientist, right? If you're passionate about criminal justice, right, and you want to be able to use data, then maybe a data science minor is all you need. If you really want to know and use data in a bigger way and apply it to criminal justice, then a data science degree is great for you. But I always try and wrap it around the passion of the student, where they're passionate now, and then tell them your passions will change, right? And flex and get it broad enough and enough skills and come back and learn more that you will always be able to change and move and go towards the passion.
So I fully embrace that. In fact, the only thing I ever tell students is this. You've got two choices. You either use this or you use this. And you should always follow this every time. This will follow it in some way or other. So just perhaps casting it in a different tack which is something we're faced with right now, and that is how we think about how these programs fit together. I mean, we all started off in some way. Typically, data science initiatives have started off with a master's program, with the basic idea that, okay, this is a 1 to 2 year program. It is for people who already have a degree of some description, and it's their opportunity to become more quantitative, to actually in some way improve their status, either the existing job or a new job that in some way probably relates to the digital transformation of society. So that's sort of how it got going, and then that's working well, for all of us, I think. And then there was, then you go to either side of that. So either, in our case, we started a PhD program, and that to create a small number of much more in-depth studies. And then on the other side, we've started a minor, and Brian Wright's sitting there, he's responsible for all of this, which is a huge number of students interested in this. And I think what's so exciting about that, per se, is that the 400 students doing it right now are involved in 40 or so different majors. So there's huge breadth of diversity of people wanting to get some level of quantitative skill. Then when you talk to those, a significant percentage of them, as much as 50% in some cases, would have taken data science as a major. So if that's the case, it means that starts to push the whole sort of lineage, because it means the students coming into our master's program are going to be much better prepared in years to come than they were in the past, because many of them done an undergraduate degree in data science. On the other hand, you've got more interest, people wanting to take, so you've got to sort of take it and all of this into account. And I think using student use cases to help drive the decisions you make about your programs is really an important way to think about it. I think people say to me, what's the best thing about your job? And I say, it's looking in the eyes of the students, because you can tell when you hit upon something that they're passionate about. Mm-hmm. You can see it in their eyes, and that's really exciting. And so helping them navigate those pathways, it's a really important question, and we certainly don't have all the answers.
Yeah, and let me just add one more thing
sure.
before we move on. You can see it in the sessions today, right? I was in a critical data studies, and I learned a little bit about anthropology and how, the data is becoming the new written language. So that was fascinating. And then we had the sports, right? And so people's passion at sports is being brought into this area as well. And so as we do that and where your degrees and how we do it, we have to manage that with both the job market. Academics hate to say that we do actually sometimes train people with skills that are actually available in the job market and our industries like. Others don't, right? We're teaching a person to succeed with life. And so we've got to blend all that together and really understand where the passions are and how we build our degrees, not just within the school, but across the universities to be able to manage this in a way that helps our students succeed.
So I'm glad you brought that. Did you have anything? No. Oh, so I'm glad you brought that up about the employers, right? Because I would say to greater or lesser extent, almost all 21st century employers are going to expect some level of critical thinking or data literacy. So how, for students who are not necessarily don't even know yet whether they want to learn more about data science, so they're not yet in any degree program, not considering a certificate, they just want to understand what data science is about and maybe attain some of those skills. Are there opportunities like that on your campus? And for example, are the libraries involved? Do they have a role in that training?
The libraries are a great partner and resource for helping people manage their data issues, but I don't believe that our libraries are particularly helpful for undergraduates who are trying to figure out what major they want to be in. I think that the only way one figures it out is that institutionally we help is through introductory classes that are designed for exploration, and there are several of those.
So one of the things we're working on in our campus is a revision of our general education. We haven't revised our general education in 20 years, so we are doing so today. And one of the things that we have decided as a university is to change our mathematics requirement into a mathematics and quantitative reasoning. So it's beginning to open up that data literacy. And so the question is, what's the responsibility of the school to be managing that? Is it the mathematics department that deals with quantitative reasoning? And I said, hey, I'm going to borrow because I like borrowing from others, and the open access allows us to do it. So the Data 8 course at Berkeley, right, has been fairly successful across their campus and has some great ideas. So we're adapting that to ours, and we'll try and participate in our general education, which has not been a role of the school so far, but we'll see how to do that as we do. But that's managing that and being able to open up our educational, and there's a few other initiatives across the country coming from our industry partners on we need at least these, and I love industry sometimes, I was there for a long time. We need these 35 skills, and then 6 months later I need these 42 skills, right? And they added a whole bunch of things and they keep adding to it. So it makes it difficult for us as universities to manage that. But they are actually speaking up very loudly and saying these are the basic data skills or the literacy skills we would love to have in all students. And then how do you get, the 35,000 students that are not in your program to actually participate in that? And that's one of those challenges we have. But Gen Ed is the way we're starting to attack that.
Right.
Let me just add a little something as it relates to libraries. I want to give libraries a plug. Partly because if you're not from UVA, you may have noticed there's a bunch of building going on here. We're currently building a School of Data Science, which is just across the Emmett Ivy corridor, and the library is just going through a major renovation, the Alderman Library. And the Dean of Libraries and I are cohort, well, we're actually motorcyclists. We're at the part of the gang called the Hell's Administrators. There's only two of us, but we're a gang. And we talk a lot about what we can do together. We're actually designing a zip line that's going to go from his office to my office across the corridor. But that's not the important point. The important,
I thought you were deans on bikes.
Well, we are, but we're also deans on zip lines, I guess. That's pushing it. No pun intended. But I think what is important is we talk a lot about the interrelationship. And I think as we evolve, the library is also evolving and to meet the whole digital enterprise. So the notion of libraries as archives for data, for providing services surrounding data, I think is an important aspect. You know, part of this, the open initiatives that we're doing here, I mentioned the policy, but behind the policy, if it's going to work, there's got to be tools and methodologies to actually make it work. And so how we get research products into archives and available is something we're working closely with the library. And at the same time, I think they also have have a role, and we have different libraries. We have biomedical library, for example, as well as the main library, and are involved in doing a significant amount of training, which is I think, complementary to what we do in the more formal curricula.
Yeah, and I would say the University of Washington is also following that path. I think depending on the institution, different libraries do have a role in the informal training. And Doug, you wanted to
and unfortunately, we don't have an iSchool, information school that is, and some of the libraries are very tied into that, and we are still working, but our library has a very much of an open access, philosophy and willing to put funding behind it. And that's very much of our partnership so far, but I do think that we need to evolve it to be more, where Phil is where the connection is there a little bit more, but that's a work in process.
Right. So related to that, if we think now about the fact that folks working in their own fields, but with very data-driven approaches, the example I gave was ImageXD, right? So researchers coming together across microscopy, astronomy, neuroscience, but they all work with image data, and there's a potential there for an incredible amount of synergy and learning. Are there places that researchers can have that same kind of synergy on your campuses, or have you thought about how to do that just on a campus as opposed to, a one annual conference?
I guess I can start. And so this is actually one of the challenges of the School of Data Science that's so interdisciplinary, right? So when you have affiliate and part-time faculty that are working, or not part-time faculty, affiliate faculty, joint faculty, and faculty that are wholly within it, what's the difference between the culture that you're building within the school and the culture that's in their individual departments and individual colleges? So bringing this together is actually a huge part of my thought process, and how do you build a culture that's both unique to the school and of value and fits into the cultures of I have 24 different departments that are part of the school. And so how do you manage that? How do you manage a global studies and a philosophy professor with the image expert in computer science and those that are wholly within the school? Building that culture is one of the challenges we've accepted to instill the interdisciplinary nature of data science.
So I think we define our primary mission as building connections across disciplines and among people. And in numbers, people join our institute as a voluntary thing. And what we found is that at all different levels of, starting from undergraduate students through faculty, we have different ways for people to join. And so we can count numbers and say there are people, we have 460 faculty who are declared affiliates. We have over 1,000 students who have declared affiliation. And what that simply means is that they like to come visit us occasionally or get our newsletter, or, it doesn't, it's a voluntary statement of, I like you, but that doesn't mean that, we're important in their lives, right? There's a difference. And I think that for a deeper engagement, those are always much smaller in number. They're sort of in this big umbrella, and we just try to create events and circumstances where that might happen. To try to fix this, the one place that we have chosen to focus explicitly as a career stage where this is most effective is postdoctoral fellows. These are people who are advanced enough in that they're following a research trajectory. They're going to be thinking deeply about research problems, but they're all usually young and flexible and malleable, unlike most of us on stage here, who've sort of set in their ways. And
You can say old. Go ahead. Just say we're old. Thanks, Jag.
I said most. That's why.
You see my reading glasses.
I was going to say all, and then I said no. Right. So I think that that's a place where we have full-time postdoctoral fellows, and that has been really important in terms of people sitting next to each other, working in completely different disciplines, sharing the data science connection, and creating a kind of a human core for all of the connections that we're trying to build around campus.
Yeah, thank you. I think maybe we should pause the moderator predetermined questions for a moment and just see if anybody in the audience has one. Right here, sir.
Stock, but I think of the feeder system, the Commonwealth
Thank you,
is
sir.
already addressing that by designing a data science course that would be taught at the high school level. If you could give us some context for that, that would be helpful.
Yeah, I'll do it. It's people here who know more about this than I, but I would say that this has become, I think, a focus for us, partly because of the interrelationship with what our state is doing. And clearly this is going on in other states around the union as well. But I think we're also engaged in it for other reasons, which we haven't really touched on during this session. But we had a session actually recently with the president where we're talking about having more diversity in the UVA faculty. And I said trying to do that in data science is like moving deck chairs on the Titanic. We've really got to go way back. We're all competing for very small numbers of people. We've really got to go back into K-12 and start really working that angle. And we've started doing that in our own small way. The state's doing it. We're also doing it. We actually are running a course right now in private school. But we actually want to expand on all of that. And in fact, I'm very keen on hiring a faculty member who's going to take responsibility for that transition from K-12 into our undergraduate programs. And we've actually had discussions about, I'm sorry, Micaela, I'm using my thumb to point to you, but with respect to ADSA as a sort of convening body for some of these. And we've actually had, so there's organizations that are trying to do this, because clearly if we start doing that, then there are students who are going to not come to UVA, they're going to go out of state. But it would be really nice if those out-of-state students decide to come to UVA. And so it's really pushing the pipeline all the way back to K-12. And, clearly the fact that the state has recognized that and added things to the curriculum, I think is really a really positive step.
Are they
maybe
related?
I can jump
Yes,
in and say
please.
what North Carolina is doing. Our Department of Public Instruction is looking at a curriculum for elementary, kindergarten through 12 in data science. They just recently completed their computer science portion of that. And now COVID got in the way to their efforts, but they are looking at that. And a lot of it's visualization, data literacy, as we were talking about. But one of the struggles we have is what is the term data science, and do elementary age people even understand what data science is or what it's capable of, and when and how do you introduce the language. But I'm also kind of looking at Phil's and would love in the future to be able to hire someone to be that intersection and be in both, most likely the high schools, maybe a little late, but if I can rely on public instruction to kind of set the curriculum that will then prepare them where we can get involved in the high schools more. We also have a Center for Educational Innovation that we work highly with the middle school, that we're bringing a lot of our new pedagogy concepts to them to see how we can bring, and how can you retain people that typically drop out of STEM type educations, retain them and keep them involved. Because if you look at the elementary school, a lot of there's a lot of diversity and interest in science, and then it wanes as you get into high school. And so that's that critical point of where we're studying, being involved in practice, but also working with our state to try and understand the curriculum that we will be changing along the way.
I'm going to add to Michigan. Okay. I saw maybe another question.
A lot of the demand, this explosion of data science programs across the country and the world has been driven both by student demand, right, and by employer demand. In the last couple of weeks, certainly the last couple of months, we've seen pretty dramatic layoffs at companies like Twitter, which was expected, but also Meta, Salesforce yesterday had a lot of layoffs. I'm wondering if you could speak about the future of data science in this new context where it may, in fact, suddenly be subject to labor market fluctuations like every other field.
So first, absolutely, I think every field is subject to labor market fluctuations, and that includes data science. But having said that, I don't believe that the current tech layoffs are central to data science in the sense that I see that as much more of a computer science thing than a data science thing. I think that a lot of, at least our data science graduates, are not going into the tech industry, but are doing data science in a whole range of other parts of the economy. And so I think in that sense, we're more diversified.
Yeah, let me address this, and I agree, we're all subject to the fluctuations of the economy, and people are projecting a recession coming up, so. But one of the things I would add to that, and in Charlotte, we're a heavy financial industry focus, but one of the things they do is pay very well. And so our data scientists are typically going into the financial services, technology industry, and my goal, and this may not be great for all the students out there, is to flood the market enough that our nonprofits and our other industries that cannot currently afford this talent, that could really use that, will be able to do that. So that's kind of a controversial statement, but to be able to enable other industries to participate through the data science talent is one of those things, and it not being I'm going to go be a volunteer today, that they can actually afford the talent is one of those things that I would like to be able to foresee in the 10-year future, is that everyone, all industries can participate in this, because today it's too expensive for many.
Well, I don't have much to add, just to say that if folks, the questions around industries that people immediately think of with respect to data science, it's already been said, it's much broader than that. I love playing a little game where I'm, with people, and I say, just name anything you want, and I'll tell you a data science story around it. So someone pointed to me out over breakfast and had that blueberry muffin. And okay. And then, you make up a story about supply chains and analysis and, and how the bakery needs to, how their AI is driving the machine and the components that go into it and so on. And the point being is data science is just everywhere. And where the slack might be appearing in one aspect of the industry, in an optimistic sense, we'll see over time, it's going to be picked up by less traditional areas that suddenly realize that their future is very much driven by data analysis.
Another question right here.
Yeah, so I think to be a successful data scientist, it sounds like one of the most important things is being able to tell a story beyond the insights that you uncover. How would you say that you train students as data scientists to be able to do that well and to go out into the world and make an impact with the insights that they uncover with the tools that they have? How do they enable organizational or business change with those insights?
Maybe I can start on that one. We have a course, and actually I teach it. So one of the things that I brought, and we listened to our industry board, was exactly that point. That communication is, your students are great at running the computer, building the algorithms, and hopefully thinking about it ethically, but can they communicate that? And so we think a lot about that. We actually have a course But there's other things out there. Books and Storytelling with Data is a wonderful book. I don't know if any of you have seen that. But that's one of those things that we brought into our curriculum because of the industry feedback and the importance of it. My background is in corporations, and so I had to teach my team how to do that, to talk to the CEOs within the corporation. So they were pushing it back to the academics to be able to do that. And journalism and storytelling and how you actually formulate a story and what you do, understanding your audience, all that's critically important, and so we brought that into our curriculum.
So my formula is public service projects. The students, many of our students really care. We've got a thing called Michigan Data Science Team, which is a club, and students go out and do projects. One of the better stories has to do with the city of Flint that had a water crisis a few years ago that you might be aware of. And the problem was old lead pipes that led from the mains to the house. So there was a question of a pipe to every home that had to be dealt with. And there weren't good records of who had lead pipes. And so one had to guess, and it cost almost half the cost of replacing the pipe just to figure out if it was a lead pipe or not, because you had to dig and cut out a section and whatever. And so predicting who might have lead pipes and investigating those homes first became a major issue and a significant public problem. And our undergraduate students as a club activity were in the forefront of doing this and developing algorithms to predict this. Sorry for the long story. What happened was that they were very successful in doing the prediction and completely unsuccessful in selling their results and earning community trust. People obviously cared very much about whose house was going to be investigated first. And saying, oh, there were these kids from the university who had developed some algorithm that was predicting something was not a good way for the local authorities to proceed. And this was really a trial by fire type of understanding how to conduct themselves, which, to their credit, the students eventually did after some initial failures.
Let me ask if there's one more quick question from the audience, and otherwise I will do a rapid fire now. Did you want to pile on really quickly on the last one? No?
That's fine.
Okay. So each of you are, actually I'm going to say the question and then I have a quick announcement, so I'll give you a chance to think about it. Each of you are responsible for a data science initiative. What do you want your initiative to be recognized for in 10 years? Which is perhaps another way of asking, how do you see the future of data science? So while you mull that over, I was told to let all of you know that there's not any formal break after this panel. We'll have a panel on careers in data science. So as soon as they've answered their question, we'll thank our panelists, and then you can get up and stretch for a minute, but try not to go anywhere. All right, who wants to take that one first?
I can go first.
Go for it, Jag.
Yeah, my goal is to transform the way our university creates and develops knowledge.
All right, so I'm going to agree with that one, and then I'm going to go on to the second one.
Pile on.
And this is kind of a different type of goal, but the real goal is for our students to be wholly engaged with the community. And so out in the community and the community recognizing that our students are actually providing value to our community.
So
Right.
I'll just say that I'll tell the same story I told to a subset of people in the other room this morning, and that is, I was just had my 5-year review as dean, and I was one of the reviewers, who I should add is also a former student who's now a professor here in biomedical engineering. The moral of that story, be nice to your students, because otherwise later on they'll come back and screw you. But beyond that, he basically said to me, you know, will we need data science in 10 years? Won't it be everywhere and everything? And we've kind of talked about that today to some extent. And really, in keeping with what Jag and Doug have said, it's the other way around. I think we'll actually be the university in 10 years. We won't need the university because I think what we're trying to do here, all of us in our own ways. I'm glad the president left, but it is really to change, in some ways, really reform, you know, in our own small ways, reform aspects of higher education that just aren't really working very well. The fact that we're not more interdisciplinary as institutions, the fact that we're not necessarily training people to actually be ready for the workforce, the fact that it takes teams to be able to solve some of the existential problems that we're facing. That's what we need to be dealing with, and that's what we should be doing in the 1 minute that's left, so that you know, we move to a better place. And that, I think, what we're trying to do is, within our respective initiatives, is move to a better place.
I was just gonna say.
Sorry.
You're totally fine. Do you want to pile on?
No, it's a shotgun round. I'm like,
Oh, sorry. I forgot about the shotgun.
The fire. Okay. Totally fine. We did get our 1 minute warning. So Phil, Doug, and Jag, thank you for lending your insights. Let's thank our panelists now.